Hello everyone, good morning, Rahul here.
Good morning, sir.
Good morning. So we'll just start in 1 minute. I request all of you to please log into Databricks in the time. So what we will be doing today is Spark, as I told you, in the first half of the day. After that, we will be talking about your respective projects. So please confirm me if you have opened your Databricks. We'll get started.
Done, sir.
Okay. What about others? Okay, I'm just sharing my screen. Yeah, sure, pushing. That's fine. Okay, guys. So if my screen is visible, we will be. I'm just logging here. So meanwhile, anyone having any doubts on Spark? You have studied something or you didn't get that? I told you to study something about Spark architecture. So, okay. So guys, I have received the project from most of you, but still I would say 40 to 50% of the people are yet to share it. So make sure you share it by end of the day today. Okay. So guys, we are getting started with again Apache Spark. In Apache Spark, in the last class, we talked about its ecosystem. Like it can provide you SQL, it can provide you machine learning. That's the major part. Then we looked at its architecture. In its architecture, we have a master node, which is known as driver node. And then we have slave nodes, which are known as worker nodes. Okay. Then we talk about memory or cache. That Spark uses a lot of memory or cache to store the data, due to which it's faster than MapReduce. Okay. So any question in this, or are we good to move ahead? Okay, considering no question. So today we have to look at the data structures. Data structures, okay. So whenever we talk about Apache Spark, these data structures are most important thing. What are data structures? In general, if you talk about data structures, we say list, array, dictionary. Normally we say these are data structures because they store our data. Data structures, they store our data, right? But in the field of Apache Spark, when you have to store data, where we store it? For example, normally we talk about files. Okay, so where to store the files, right? Where to store files, as in which data structure should we use? So here we have three data structures: RDD, DataFrames, and datasets. I talked about this in the last class, just the name. That whenever we have any data on which we want to do some machine learning or some SQL, anything, we have to first load that data in the form of an RDD or a data frame or a data set. Okay. Any question? Okay. So RDD is the core. I would say the core, the most important part. Because I told you in 2011, RDD was there. 2013, they added data frames, and 2015, they added data sets. So core is still RDD. So whenever we will store a file, we will create an RDD. RDD stands for Resilient Distributed Data Set. RDD, Resilient Distributed Data Set. What I mean by this, let's say you have a file, you load it into an RDD, you create a RDD. What happens is this RDD, it gets split into small blocks known as partitions. Here we say at partitions. A RDD splits into partitions, partition 1, partition 2, partition 3. So that's why it's known as distributed. An RDD is split into small partitions. It's same as blocks, as you talk about blocks, right? So RDD does not get split into blocks, rather it's known as partitions. Okay, and those partitions, they are distributed across the cluster. That's why it's distributed. Data set, because RDD always stores some data, right? You loaded this file in RDD, so it is a data set only. On this data set, or let's say on this RDD, you can do machine learning, SQL, anything. Resilient. What is resilient? Resilient means anything which is fault tolerant, that can tolerate the failures. What is the meaning of that? Each partition, like here we have one partition, right? Each partition is replicated 2 more times. Same concept as blocks, right? Same concept, guys. It's the same concept as blocks, just the name is changed. In RDD, instead of saying blocks, they say partitions. So each partition is replicated. Replica 1, replica 2. So let's say if this partition is lost, its replica is still available. So that's why it's resilient. It's resilient distributed data set. So if someone asks you an interview, please remember to explain what is RDD. Resilient, why it's resilient, why distributed, and why data set. Then we have data frames, Spark data frame, which is different from Pandas data frame. We discussed in the last class, and then we will talk about data sets. Okay. If no questions, let's move ahead into the hands-on. So guys, quickly start your cluster, please, all of you. Confirm me if your cluster is started. So as I told you in the last class also, we are going to the Databricks cloud and starting a Spark cluster. It's not a Hadoop cluster. Remember, it's not a Hadoop cluster, means the storage is also not HDFS. We are not using HDFS here. Spark will use something internal. Okay, this cluster will use something else to store the data. Remember, I told you that a Spark cluster can exist separately. having its own worker nodes connected to a driver node. A Spark cluster can be a separate cluster. A Hadoop cluster can be a separate cluster having its own data nodes connected to the name node. You can have a Hadoop cluster separate and a Spark cluster separate, or you can have Spark running on the Hadoop also. That is also possible. Okay, but in this particular case, I told you that we are not using Hadoop. We are not using Hadoop. This is just a Spark cluster using Spark for its processing, but for storage, it will use something given by its cloud partner. The cloud partner here is Amazon. It's Amazon AWS, so it uses AWS storage. Remember, I told you Spark does not have its storage. Okay, Spark does not have its storage. So here in this case, it may be using a cloud storage. Spark only gives you processing. It needs to use someone else for storage, either a cloud storage like AWS or Hadoop storage like HDFS. Okay. So that should be very clear. Don't start the cluster, please, Lokesh. So always create a new cluster. So someone asking me if I want to start this clusters, definitely you can start this by clicking on this start button, but that takes more time than starting a new cluster. Better create a new cluster, always create a new cluster rather than starting an old cluster which was terminated by you earlier. See, whenever a Spark cluster is getting started, it's showing you some drivers and workers. Driver is nothing but how many master nodes you have. Worker means how many slave nodes you have. Masters and slaves, how many masters, how many slaves. In this cluster, we have only one node. So that one node can only be a driver or a worker. So in this, we have only one node. And if you see, whenever you create a new cluster, guys, if you see that, you will see that you get only one node, which is the driver node, because master is always mandatory. So this cluster has only one node, which is the driver node. There are no worker nodes, but in this case, driver will play the role of worker also. Whenever you have a single node cluster, that single node plays the role of both driver and worker. Same in Hadoop also. If you have one node, it will play a role of both name node and data node. Ideally, it's not a good practice in real world, but for hands-on, we are fine. For us, it does not matter, because our purpose is coding, not looking in the configurations of the cluster. That is the admin's work, Hadoop admin or Spark admin. Okay, guys, please quickly confirm if your clusters are up and running. Mayank, I'll come to that because that's the most important question. When to use RDD, when to use DataFrame, when to use dataset. That's the core question that we are going to solve. So if you didn't get that answer by end of the class, please ask me today. Okay, Madhu, thanks. You have cluster started. Shivali. Okay, Mayank. Perfect. So guys, once your cluster is started, which make sure you always do before the class starts, just start the cluster. Now go to your notebook. Okay, go Either you can create a new notebook, okay? But even before that, we have to do something else. We need data, guys. We need data on which we can do analytics, right? So we can go to internet and download a file. Let's say I'll ping you the link. 1 second. So I'm pinging you a link, guys. Please download the data on your local laptop. If you go there, you will see this download link. Please download the data file. And it is not mandatory to download this file. If you have some other file, you can use that. But better to be consistent. Whatever file you have, just unzip it. So we have so many files. We'll take a few and do the analytics. I'll wait for you to confirm if you have downloaded the file and extracted it. Very good. So what we will do, guys, see, consider it like that you already have some data on your laptop, okay, that you want to use in Spark. Okay. So what we will do, we will take any one of these files. Let's take players 20 file. Okay. So once you have the zip, extract it, and we will take only players 20 file, huh? And we will use this file for some Spark analysis. So what we have to do, see, it's very simple. Go to the Databricks website, and here, as in the Databricks cloud, go to data. Okay, data, that is the storage part. Let's say if you were using Hadoop, it would have been HDFS. But here we are using Databricks cloud, so it is using something else for storage. Spark does not have its own storage. I am telling you again and again. Okay, so this storage is provided by the cloud partner of Spark or the Databricks. Let's click here. Here you will get an option to create a table. Don't worry about the word create table. We are not creating a table. Just click on this. Here you have an option to upload a file. We will simply click on this, drop files, or click here. Just click on this. Just go to that downloads folder and select players 20 file and upload it. This 8 MB file is getting uploaded. So that means from your local, you are sending this file to the cloud, the storage layer of the cloud. Consider like HDFS. You are directly uploading it to HDFS. It is not going to the Linux part and then it will go to HDFS. No. Consider that this utility is directly moving the file in HDFS. Okay. So in the previous classes, what I told you that if this is a data node, it always have a local storage and a Hadoop storage, right? So you used to first put the file here using some FTP, and then you used to put it in Hadoop, right? But this utility that we have just used, no, that utility will always directly upload the file to Hadoop. It has that access, okay, to HDFS. Whatever is your distributed storage, whether HDFS or whatever. Any question?
No, sir.
So the file that got uploaded, it didn't went on to the local storage, it went to the distributed storage. Just use this term, local storage and distributed storage. Because the distributed storage can be HDFS if you are using Hadoop, but if you are not using Hadoop, it can be something else like Amazon's S3. We can use Amazon's S3 also, or something known as here. What is DBFS? This is Databricks file system. Like HDFS, like we have HDFS, we have DBFS, Databricks file storage or Databricks file system. So guys, again, I told you, right, in the Databricks cloud, the storage layer is not HDFS, it is something else. So that is known as DBFS. So the file that you uploaded, no, that is uploaded in the DBFS. Okay. And this is the path. This is the path of DBFS. We will be using this path. This file is uploaded to DBFS, which is like HDFS only. So what you need to do, you need to copy this path, but abhi process complete nahi hua hai. Process is not completed. You have to click on create table with UI. Just click on that. Click the cluster on which you want this table. So select the cluster that you already have running. Preview the table. It's just showing you some sample records of your file which were uploaded. It knows that it's a CSV file. See, the data automatically got loaded in a good way, but see, the first layer, the first row contains columns. So we will select first row is header, select left hand side, first row is header. And as I told you, I always prefer using string. Even though age is an integer column, I prefer using everything as a string whenever I'm ingesting the data. Later I can change it based on my need. Okay. Click on the create table. I hope you have that path already copied. Copy that path somewhere. Even if you get this error, don't worry, it get created. Sometimes this error comes, but it's fine. It's already created the file. So I'll wait for people to ping me if they have done this. You have to go to your cloud, go to the data section. See, this file is uploaded. Okay. Click on the create table, upload file, click on this upload file. Select whichever file you want to use for analytics. Whichever file you want. It will upload. But you have to now click on, first of all, you have to copy this path. This is DBFS path, not HDFS path. There is nothing like DBFS, okay? There's Databricks given their own fancy name. But it helps you to compare that, okay, I am not using HDFS, I am using DBFS. So like we were using HDFS, here we are using DBFS. Just create table, preview the table and see if everything is looking good. The first column, the first row is your header. So click on this and that's it. Click on the create table button and that's it. Forget about this error, don't worry. Sometimes ideally it never happens in the real world, but it's fine. Important is you should go here and check, yes, all the files are looking good. So you have to upload just this file, players 20. If you want, you can upload this also. Okay, Lokesh. What about others? Is the file uploaded? Arushi, Adhyan?
Done, sir.
Done?
Sir, where should we paste that link, sir? Copied link.
Oh, okay. But it was there. One second. Okay, I have pasted it again. Please follow along. It's a very simple process. So now things are easy as compared to earlier. Now things are easy when you're working with Spark. Uploading a file is very simple. That file got uploaded. Even that file creates a table also. We will talk about that later. But currently just focus on the file that gets created. I am waiting for few more people to confirm me. Okay. Perfect. So now the file is already uploaded and we are ready to do the analysis. What I mean to say is we have the files now. We have the data files. Now we have to either use RDDs, data frames or data sets. So guys, today we will first start with RDDs. Okay. So let's see how to create an RDD. Then we will see how to create a data frame. So first, how to create an RDD. Now create a notebook. Go to the notebook and create a new notebook. Let's say data analysis or whatever name, data analyst. So today we will be directly starting with Spark. In the last class, we talked about Python and then Spark. So whenever you have to work with Spark, there is a variable known as SC. Please write SC and control enter. And see, it will print you something. Please do this. Write SC and control enter and see, you will get Spark context. It is already there. It's a spatial variable. Please check it and confirm me if it is there. Perfect. See, sometimes it may happen that your Spark context, see, this Spark context is an object. If you know object-oriented programming, this is an object. This SC is an object of class Spark context. So it's like object-oriented programming. But what I'm saying, there is a Spark context class for which we have an object known as SC, and using this SC, we will do everything. So Spark context is the core of Spark. If, let's say, for any one of you, it I'm just giving you an example. I'm just giving you example. Don't get confused. Okay. Let's say you would have written SC only. You would have written SC only, but it would have said, hey, SC is not defined. If it would have said SC is not defined, then there would have been a problem. Means your Spark cluster having some problem with the Spark context. So always make sure you never get this error. So whenever you are typing SC, you should get the Spark context that, okay, yeah, this variable is there and this variable is of the type Spark context. Rest, there are just additional details. The version of Spark, master, app name, forget about that. So Spark context is the core of Spark. Let's look at the architecture. If you look at the architecture, I told you, see, this is Spark context. Whenever you are submitting any program to driver or the master, it needs a Spark context to run your program. Without Spark context, your program cannot run. So Spark context is the heart of everything. It talks to the yarn, then it starts the executors on the worker nodes. Executors runs the task, talks to Spark context time to time. So Spark context is the heart of your system. Okay. So this Spark context object have lot of functions. Guys, if you look here, when you used to do import pandas as PD, can anyone tell me what is PD?
Alias name.
Alias name.
It's like an alias, right? And using PD, what you can do, PD dot read CSV. So this read CSV is a function, right? So PD is an alias for this pandas package, and this PD internally contains a lot of functions: read CSV, write CSV, compare data frames, whatever. So same is the case here, that SC, it's, you can say, like an alias. It's like an alias, or the better word is its object. It's an object of the class Spark context. Here it's not an alias, actually, it's an object. But yeah, this object itself has a lot of functions to read files. We will talk about it, but I hope you are getting the comparison that why SC is needed. If I read any file using pandas, it will also create a file. If I remember, it creates a data frame. I can create a data frame like this, and I can also create a data frame like this. But can anyone tell me what will be the difference between these two data frames? The one created using pandas and the one created using Spark.
So it will be distributed the Spark one.
Excellent, excellent. That's what. Yeah, then. So I can create a data frame by reading a file, but my purpose is that that data frame, the data frame which will get created, will be distributed. So that's why we have to use Spark context. We cannot use pandas, or we should not use pandas. It won't be distributed data frame, right? I hope you all are getting. You can run this command also, but whenever
Yes,
you
sir.
run this, whenever you will do any processing on this data frame, it will always be running on a single data node. It will never be distributed. So that's why we should not use this. We can use that. We saw in the last class also. We did that, but that is not the purpose. So now, starting today, guys, you should understand the power of Spark, and specifically the Spark context. But this Spark context, it's not an alias.
It's an object.
It's an object. I was just trying to create an analogy, but it's SC is not an alias, it's an object. So now this Spark context has a lot of functions. Functions to create RDDs, functions to create data frames and data sets. So we have to start RDD. So the function to create an RDD is text file function. So and it is not going to be a data frame, right? It is going to be an RDD. So let's say RDD1, give it a name RDD1. And what is the file path? This is the file path. Let's put that here. Guys, are you getting my point? Hey, Spark context, please. There is a text file. Please read that text file. And so this text file function, it always creates an RDD. So you can say it's ABC. So this ABC will be an RDD. Let's run it. It's done. Now let's say I want to see the type of ABC. Type is a Python function. So because I'm doing PySpark, this is PySpark, right? Because see, Python, we are doing Spark with Python. So that's why we can use Python functions also. But saying, hey, it's a PySpark RDD. It's an RDD. So let me ping you all this thing. Please create an RDD. Check its type and let me know. So if someone asks you how to create RDD, this is the answer. You can even type ABC and run it, control enter. It will also tell you what kind of RDD it is. RDDs are also of multiple kinds. It's a map partition RDD. There are parallel RDD, map partition RDD, pair RDD. You will understand these things slowly. But yeah, there are different kinds of RDDs. Just check it. It's a map partitions RDD. Now the question is, you want to see the data for this RDD. So the function you have to use is collect. And as soon as you say collect, it will run a Spark job. It will show you the data. It's showing you the data in a very weird manner. Anyways, that's fine. So you use collect function to collect the data, as in to read the data. But let's say file contains too many records. So you have another function, take function. Let's see this one. Take 10. Let's say you just want to see the top one record, top two records. So take the first record. So it showed me the first record. This is the first record. The first record from the file is a header. Because see, we are reading the file. Huh? Because we are going and reading the file, the first record in the file is the header. So this is the header. So this path is the HDFS path or DBFS path. It can be anything, but it needs to be a distributed storage, not local storage. So you will say, hey, please read this file, create an RDD. You see the type of the RDD, you see the sample data from the RDD. So all those things can be done. Please confirm if it is done. Very good. So now we are seeing that how to create an RDD, look at its data. Then we'll see, oh yeah, it creates a job also, Spark jobs, and you're looking at the data. But the data is not in a tabular format. See, the biggest problem with RDD, the data is not in the tabular format. So doing the analysis is quite difficult. Okay, because we always are having the habit of working with tabular data. This data is like you're reading a simple file and doing something. So to do the analysis, RDD contains a lot of different kind of functions. So there are two kind of functions in RDD. Let's go ahead. Let's say I want to do some analytics. I want to see who is the player, for example, the player, youngest player. So I need to do some analysis on the date of birth, right? Who is the youngest player? Who is the most, who is the tallest player? Who is the most having heaviest weight? How many players are for this particular nationality? So, or how many players are for this club? So if I have to do that kind of analytics using RDD, yes, I can do it, but there are certain functions which I have to use. So now what you will do, you will say, hey, RDD functions. So let's open this. This is a good link I'm sharing with you. So whenever we are working on, guys, Spark RDDs, okay, we are working on Spark RDDs. We know how to create it, how to see its data, right? That means what I am trying to say is Spark context contains a lot of functions to create a RDD data frame or a data set, right? But once you have an RDD, now this take function is a function of an RDD. This take function is not a function of Spark context. Are you getting my point? So what here we were talking about is Spark functions. Here we are talking about RDD functions. Are you getting this? This text file is a Spark context function, but this take, collect, these are RDD functions. These are not Spark context functions. I cannot say sc.take. If I say sc.take, it will say, hey, this Spark context, okay, or the remote context, whatever object has no attribute take. So this Spark context or the remote context object, as I told you, SC is an object. It has no attribute or a function known as take. But if I say ABC, it runs a Spark job and gives me the data. Okay. So please be very clear about it. So what we are now talking about are RDD functions, not Spark context functions. So in the next class, when we will create data frame, we will talk about data frame functions. Then in the next class, when we will create data sets, we will talk about data set functions. So you should be very clear with this. that here we are talking about Spark context functions that creates either an RDD data frame or dataset. Once you have that thing, then you will learn the functions specific to that thing. RDD functions are different, data frame functions are different, and dataset functions are different. For example, this is not the right function, but I'm just telling you. For example, let's say this read file is a function that also reads a file, but it creates you a data frame. Whereas text file is a function that reads the same file, but gives you a data frame. Gives you RDD, sorry, gives you RDD. So Spark has different functions to create either data frame or RDD. But once you have that particular thing which you need based on your requirement, which I'll tell you, then yeah, I need only RDD, you will use RDD functions. You cannot use RDD functions on a data frame. You cannot use data frame functions on an RDD. So all functions are different. I hope, is it making sense?
Yes, sir.
Okay.
Yes.
Yes, sir.
Okay. Thank you. Perfect. But the read file function, there will be a separate function. We'll talk about that. So we created an RDD, but now we have an RDD. So I told you few RDD functions: collect, take, right? So let's see how many RDD functions are there. So in Spark, once you have the RDD available, which is a resilient distributed data set, as in the file is already loaded, we'll just scroll down. Let's leave it. There are a lot of ads on that particular page, so I don't want that. Okay. Anyways, now where is it?
सर आप वो यू ब्लॉक ओरिजिन भी एक डाउनलोड कर सकते हो, उससे कोई ऐड नहीं आएगा फिर अगली बार।
क्या नहीं होगा
सर?
अच्छा, ऐड नहीं आएगा।
हाँ, यू ब्लॉक यूट्यूब का भी किसी चीज पर आपको ऐड नहीं देखना।
परफेक्ट। नहीं, एक्चुअली जो भी इंफॉर्मेशन है वो स्पार्क की वेबसाइट पे है, बट आई वांट टू मेक इट सिंपल फर्स्ट बिफोर गोइंग देयर. Like if you look here, let it open. You will be looking at this actions, transformations. So I'll explain you this. Let it open. Okay, guys. So once you have an RDD created, no, so we have to run certain functions on it. That functions are of two kinds: transformation functions and action functions. I'll tell you what is the difference between the two. But whenever you are working on RDDs, you will be doing some computation, some analytics using certain functions. So you should know which function to use when. Before that, you should know whether I should use a transformation function or an action function. So what are transformation functions? See, transformation functions are those functions which when applied on one RDD generates a new RDD. Let's say you have RDD1, you did some transformation on it, it gives you RDD2. You did some transformation, you will get RDD3. You will never see the output. By applying transformations, you will never see the output. Whenever you have to see the output, hey, what is the data loaded inside RDD2? you have to use actions. What is the data loaded in RDD3? You have to use actions. For example, let's say you uploaded a file in this RDD for that football players. Now you want to filter the data. Let's say RDD.filter, and you created a new RDD2 which contain only players from India. So this RDD now contains a data set for India players. Means you applied some filter. So filtering is a transformation. Means you transformed this RDD and you get a new RDD. But you can never see the output. If you have to see the output, you have to use functions like collect, take. All those functions are action functions. But filter function is a transformation function. Are you getting my point? Before I move ahead. So whenever we have to work on RDD, we have to use either transformations or actions, depending on what I want to do. If I want to do filtering, joining, that kind of things, these are just transformation functions. Transformation, I'm doing data transformations. But when you actually want to see the data, you will use actions. I'll tell you that, Rahul, why transformation separate, why actions are separate. I'll tell you the reason. So if you go to any website, you will see under transformations, you have functions like map, filter, some unions, intersections, as in you want to union two RDDs, intersect two RDDs. Like union function, what it will do, returns a new RDD that contains all elements and arguments from the source RDD. Then you have actions, like we used collect, take. Take always needs one argument. First, if you only want to see the first record. So take with value 1 is same as first. First function is same as take function with argument 1. So first, take, collect, count. Let's say count. Let's use count. You want to count the number of records in this RDD. Total 18,000 records are there. So there is a count function, separate count function available. So are you getting my point? In SQL, you used to do select star, a count of star from a table. It is not SQL. It is Spark RDD. And behind every time it is running a Spark job, not a MapReduce job. But have you noticed that while running this command, no Spark job got executed? But while running this function, Spark job got executed. That's the difference between a transformation and an action. A transformation will not immediately run a Spark job. Action will immediately run a Spark job. That's another difference. We'll see more. Anyways, that was just a graphical thing that I wanted to tell you. Even further, transformations like okay, yeah. If you look here, what I'm telling you, you have on RDD, you have transformation functions or you have action as functions, two functions. Transformations further are of two types. We will talk about that later. Transformations further are of two types, but yeah, we have transformations and actions. Transformations will never run the Spark job immediately. Actions will run the Spark job immediately because they need to show you the result. If you look here on an RDD, when you run an action, it gives you the result. On an RDD, whenever you run an action, it gives you the result. But whenever, see, let's say this was one RDD, you applied a transformation, it gave you another RDD. You applied another transformation, it gave you another RDD. So it keeps creating RDD. So it creates a graph of RDDs. First RDD, okay, another transformation, second RDD. So it's like creating a type of a graph known as a DAG, directed acyclic graph. I will talk about that. So this graph is nothing but this graph: RDD1, RDD2, RDD3, RDD4. Any questions before I move ahead?
No, sir.
Okay. So yeah, first we created an RDD. Then so far we haven't applied any transformations. Even this, you should not even say this is a transformation because this is not a RDD function. This is a Spark context function, right? So far we haven't used any transformations. We just use a action. So we created an RDD. Then on RDD we just applied an action. We haven't applied any transformation. So we'll apply that. So I hope you all understood this diagram, that whenever you apply a transformation, you will generate a new RDD. You just generating RDDs. But when you apply action, you get the result. I am pinging you another link to study. This is actually the better link. So whenever you will go to Spark's website, see, this is the best place to read. But they just lack graphical representations. That's the only thing. So when you have an RDD and you have to do RDD programming, not the data frame programming or a dataset programming. So we are talking about resilient distributed datasets, right? So once you have the RDD, you applied some functions or operations on it. So functions or operations, whatever you say, they are of two kinds: transformations and actions here. So you can read from here. Let's click on this. So when I click on transformations, I came here. Map, filter, flat map, map partitions with index, sample, union, intersection. You can read about it. We will talk about that. Join, group, co-group, Cartesian, pipe, coalesce. Actions like reduce, collect, count, first, take. Okay. So we have that. Anyways, whenever you want to see some samples for your practice on this website, you will see by default Scala, but we will not use Scala, right? Spark was built in Scala, so they show you Scala, but they also show you Java program also. Java RDD, how to create an RDD in Java. Same function, see, Spark context.txt file, but it creates a Java RDD. Here also see the same function. Scala also has the same function, but some syntactical differences. But you always should click on Python. So this is what we did. Text file. We got the text file, intended text file, right? And then we created an RDD. So this is our RDD. Okay. Now we can apply. See what's happening here. This is your RDD. He applied another function, a transformation function, on an RDD to get another RDD. Okay. So you keep getting an RDD we'll talk about that, what he's doing. Okay, let's come back to this. So let's create some scenario what we would like to do. So whenever you have a RDD, you can use the first function to see the first row and identify what can be done. So let's say based on nationality, I want to filter the records. Okay. It won't be that straightforward here. 1 minute. Let me first show you this example to make it easy. So we already have a file available with us, but I'm showing you one example before I go into that and the problems with the RDD, and then why we move to data frame. You will understand that why we move to data frames. Okay. So I am showing you. So before we go into that analytics on filtering data based on nationality, I want to show you how filtering is normally done in RDD. Let's say, guys, you have you want to create an RDD. Okay, you want to create an RDD, but this time you don't have any file. You have an array or a list. Let's say you don't have a file to create an RDD, but you have a list, dictionary, array, tuple, that kind of a thing. And I say, can you convert this into a RDD? So we have another function known as parallelize. So if you have a file, you will use text file function. But if you have an array, list, tuple, that kind of an object, and you want to create an RDD from that, you use parallelize function. So what will happen? See, this array will always be stored on a single node, always, even if it has like this data. What I'm trying to tell you is, if this is an array or a list, even if it contains millions of elements, they will always be stored on a single machine. But if you want to distribute this list across the cluster, you will convert it into a RDD using sc.parallelize function. So it's done. So let's see the type of RDD. So this is another kind of RDD known as parallel collection RDD, but it's also an RDD. Now you want to filter the data from this RDD and want to see those records which are, let's say, greater than 5 or greater than 7, those values which are greater than 7. So how will you do that? You will use a RDD dot filter. Let's remove this. This time you want to use a filter function. This is a transformation. So on this RDD, you are doing some filtering, and this is Python lambda expression. You say lambda x divided by 2. So our requirement is not this. Our requirement is just if x is greater than 7, right? You just want to see those records, right? So I will get new RDD2. See guys, understand it. What I am trying to tell you, whenever you have a file, this is how you create an RDD, sc.text file. Whenever you have a list, tuple, array, and you want to convert that into an RDD, so sc.parallelize and that element, that will create a parallel collection RDD, a Python RDD. Here you see Scala, because behind the scene everything is a Scala. Like in MapReduce, like when you were doing Scoop, Hive, everything was Java. In Scoop, Hive, everything behind the scene was Java. Here everything behind the scene is Scala. But you are writing a Python program. It automatically gets converted into Scala and runs. So this is your Scala program, which is executing behind the scene. And this is the line number of that program which is running. So you don't need to worry about what that program is. But now what I am saying is, I want to filter using this lambda expression. So I get a new RDD, which is Python RDD. Let's see, now you want to see the data. So this time the function that you will use will be the action function. See. Are you getting this filter? Before I go into filtering this complex data, I wanted to explain you a simple filtering. Do everyone understand this lambda expression, or you want me to explain it? Yeah, what? Your voice is breaking. Guys, anyone who is not aware about the lambda function in Python? So Madhu, I hope you are getting my point, that you already know that these are transformations and these are actions. There is a list of functions, right, Madhu? That okay, these are transformations, these are actions.
Okay, sir.
But when to use which depends on the requirement which we are learning here. Yeah, Pankaj, that command you have run will give error because you have missed the lambda expression, no?
Like I write all the things like lambda functions and all that, but I want to know like the transformation is doing the function, but the creating the new RDD will be done automatically, or I have to every time just named it.
Yeah. I'll tell you. You have to name it every time.
Okay.
1 second. Okay. Yeah. 1, 2, 3. Okay. So let's understand this. That's why I came to the simple example before the complex one. Guys, whenever you talk about this array, when I converted this into a RDD, what will happen? In this RDD, the first row will have value 1, second will have value 2, 3, 4. Each of these will become a row. Understand it? 5, 55, like, okay? ये तो सबको समझ आता है? Whenever I am converting this RDD into RDD, each element will become a row. First row, second row, third row, fourth row, fifth row, second, third, like that, rows. Every element will become a row. Okay? Because it was a list. Now, on this, I apply a filter. I apply a filter, this filter. Now, what the lambda expression do? The lambda expression, this colon is important. On the left hand side is the input, what input it is getting. Okay. This is the input. And this is what you want to do with that input. So this is the input that will come to you, and this is what you want to do with that. Or you can say this is output. This is input and this is output. This is left is input, this is output. Simple. So when I am using a filter function in the lambda, I am passing this x as input, like 1 as input, and output I want 1 greater than 7. So 1 greater than 7 will return what? Can anyone tell me?
False.
False. Very good. So this lambda expression, when get evaluated, it will take 1 as input, and the output of this lambda expression will be false. After that, filter function will come into picture. Whenever it sees false getting returned, it will not give that value in the output. Filter function will stop the false. It will not allow the false to go into this new RDD. So all these records will not go into that new RDD. When 55, which is the X in that case, will go, and output will be whether 55 is greater than 7, true. So filter will say, yeah, this is evaluated to true. That record should go. So that's why when I collected the data, I saw the data greater than 7. So first the lambda expression will take input and give output. And on that output, the filter function will take decision whether to send it to the new RDD or not. So you always need to give this name of new RDD. System will never know. So you always need to assign the output to a new RDD. So remember that whenever you are applying a transformation, it should always be assigned to a new RDD. But whenever you do actions, see, even if you have noticed here, guys, guys, did I got disconnected? I think.
Yes, sir.
Yes, sir.
At what point?
Like you said, we have to always create the new RDD. Give the name.
Yeah. So I was saying that whenever you are applying a transformation, you should always assign it to a RDD. But whenever you are applying an action, you don't need to do that, because it will throw you the output immediately. No?
Excuse me, sir.
Yes.
Your screen is not visible.
It got disconnected. Okay, so whenever you are, is it visible?
Yes, sir.
So
Yes, sir.
if you look at whenever you are doing a transformation, it needs to be assigned to an RDD. Whenever you are doing an action, it immediately gives you the output. You don't need to assign it to any new variable. Okay. Okay. Any question, any doubt? Let me even show you one interesting thing here for clarifying your concept. Let's say you assigned it to a variable. Let's say variable x1. Let's say you do this, and here this was a transformation. You assign it to a variable. This is a variable for you. You don't know what it is. It's a variable. Let's say x. And on that x, when you applied a collect function, you will get x1. Now let's see this. Use type function on x and use type function on x1. See, understand the difference. When I was applying a filter function on an RDD, okay, filter function on an RDD, it was giving me a variable, x variable, which is nothing but a RDD only. But when I applied a action, and if I even assign that output to a variable, that variable will be a simple list. It is like it's a Python object. It's no more a distributed object. It's no more a distributed object, no more a Spark object. In Spark, you have only 3 objects: RDD, data frame, data set. So whenever you are applying any action, the output will no longer be an RDD, data frame, or a data set. No, it immediately gets printed on the screen or it gets collected. Let's understand it in a better way. You have these as your worker nodes. Let's say this X was a RDD. It got splitted and some part is here, some part is here, some part is here, some part is here. When you say collect, so all the data will come together. It's getting collected on a single machine. So all the data gets collected on a single machine so that you can see the output. So collect function, what it do? It collects all the partitions for an RDD and collects it on a single machine. That's why it's a simple Python object. It's no longer a distributed object. So the output of an action is always a Python object, a collected object. It's never a distributed object. Are you getting my point? Any doubt? But the output of an RDD based transformation is a RDD only. This was first RDD, this is second RDD. Any question? So let me ping you this program. Just run it first, then only you will understand it more. So we have seen how to apply an action and a transformation. We will look at it in detail. And as I have already shared with you this documents, let me share this link also. Read more about it. So we have seen how to create an RDD from a file or how to create an RDD from a list. Then we have seen a simple transformation in action. Now we will be going into a complex thing, which is how to apply the filtering here. But before that, we will take a break. Okay. We will be back at 12:50. Okay, 11 minutes. So please be back at 11:50. Okay, guys.
Yes.
Be back at 12:50. Be back at 12:50. Guys, please let me know if you're there.
Yes, sir.
Okay, perfect. Yeah. So let's see this. So what I was saying is, given a file, you can create an RDD, or you can create an RDD from another collection of objects. So this is another collection using this different function. Okay. Now, there are different kinds of transformations that we can do on an RDD. Like say you have an RDD, RDD dot map. So you can use different transformations like map, filter, reduce. I shared with you a list. What map do is you use a lambda expression, x, and x. Let's say you get this as input for every record which is coming, and this is as output. So you want to increment each value by say 1. So let's say RDD, no, I need to create new RDD, RDD2, and I will say RDD2 dot collect. I want to see the data, right? Let's see that. So now if you look above, you have value 1, 2, 3, 4. Every value is incremented by 1. So are you getting my point? What lambda do? Lambda will simply take input and give you output. Lambda functions or lambda expressions takes inputs, gives you output. But what you need to do on that output is decided by this function. Whether it's a map, reduce, filter, what function we want to use here. Map function, it don't do anything. It just prints the output, whatever you have. It is just doing the operation and printing. Okay. So filter was a different thing. Map is a different thing. These are all transformations. The only important thing to remember here is that this is one record, this is another record. Everything will be treated as a different row. So these are all different rows. So here, this is a transformation and this is a action. So it depends on what you want to do. You just want to iterate over an array and increment its values by 1, you will use a map function. You want to do some filtering, you will use filter function. So these are different kind of functions available to you, or transformations available to you. Okay. And finally, you have actions, as in you want to collect and see all the records. You want to see only the first record. So it's the first record. You want to see the top 10 records. So Madhu, are you getting the answer to your question? Like each action and transformation has its own function. So you should study and understand which to use when.
Yes, sir. Yes, sir. Got it.
Okay. Now let's say instead of incrementing each value, you want to print something like this. Value and 1. A key, you want a key value pair as output. See. For every input, you want the output as a tuple in the form of the value and 1. Value and 1. If you remember, there was a word count problem. If you want to do word count, like how many times 1 is coming, how many times 2 is coming, 3, 4, 55, how many times each number is coming in your list. If you have to do that kind of a operation, you can do through this approach. Remember the word count problem. Guys, remember the word count map reduce?
Yes, sir.
Yes, sir.
Let's say if instead of this I would have some
Yes.
word, how many times 1 is coming in this list, how many times 66 is 667 is coming in this list. So I first need to convert it into this key value, and then the reducer used to run, which gets all the same keys and add the 1111 for them to give you the output. So same thing, if you want to do through Spark, the word count, you have to use the map function, lambda operations, and then some other grouping and similar kind of operations. Okay, but now let's come back to the original problem. Here we had the data, but each row is not a single column. Each row itself contains multiple columns.
Oh my God.
So can anyone tell me what should be the solution for it? How can you solve it?
Which one?
Bala, you are there?
Yes, sir.
What happened?
Nothing, sir. I just got little work. I went.
Okay. Uh, no problem. If it's urgent, you go and do that work.
Yeah, I'm back, sir. I'm back.
Okay. So guys, what I'm saying is you should understand that when I was talking about this kind of data, you had only one column. Consider this data as this. Each row contains only one column. So filtering was very easy. Are you getting me? If you have an array, it's like a single column. Let's say this is salary of all people. You want to see all those salaries which are greater than a particular value. So you could have filtered it easily using a filter function. That for every X which is going inside is a single column. But here, can anyone now tell me how can I filter this based on a single column? Any idea? I want to do something
With
like
column.
the biggest problem with RDD is they don't have any column name. In RDD, there is no column. All these are this is like a record only. RDDs don't have any headers. They don't have any schema. RDDs are schemaless. You cannot use RDD for simple SQL kind of operations. So nationality is like a word. It's not like a column. It's just one of the word in this list. If I say X given, let's say what nationality, let's say equals India, let's say, that's what you are saying, right? Hey ABC, please filter using a lambda expression for a input X, fetch the nationality field and check if it's India. But for it, nationality is not a column, so it won't know what is nationality. Let's say you assign it to a new RDD and L dot collect. It failed. Huh? The job failed because it's saying, hey, I don't know. There is a name error, Python's name error. What is this nationality? I don't know. What is this nationality? I don't know. So you say, okay, let's say X dot nationality. Okay. Spark is executing and job is again failing. It does not know what is nationality. So that means nationality, it's not understood here. So that's the biggest problem with RDD. Like they don't have any schema. One second. So this, the first row for it is just a first row, like any other row. It does not give any special preference to the first row in the file. It is treating that as a data row only. So I cannot do this filtering. So let's see if I can do something with map. That hey map, let's take the entire row in the input and x dot split everything based on comma. See what happened now. I split it everything into column. What I did is I said for every input x, which is a row, split it based on comma. So this first row will be splitted based on comma, and like that every other row will be splitted based on comma. So I will get FIFA ID, player URL, short name, long name. So like that. Okay. But now, which is the index number for nationality? 0, 1, 2, 3, 4, 5, 6, 7, 8, 8. So 8 nationality in this array is at the 8th number. Let's put another map on this and another lambda expression. For the input x, you want to see x8. Let's see that. This is another new thing for you guys, maybe applying a function on top of another function. This is known as functional programming. On the output of one function, you are applying another function known as functional programming. So first this part will run, and after that this part will run. So I'm getting nationality and Argentina. Done. I took let's say I take the first 10 rows. Nationality as Argentina, Portugal, Brazil, Slovenia, Belgium, Germany, Croatia. So guys, I want to be very specific. What we are doing is, hey RDD, apply a map function. So first of all, this row, it does not know what is nationality. You does not know what is nationality, meaning of nationality here. You have to first split everything. So this entire line will become an array. And on that array, the 8th element is nationality. So let's say what you want, what you are interested in. You want to know how many players are for a particular country. So you'll take the nationality column. That will come. Then you apply a filter. Hey, please apply a filter. For input x, is x equal to, let's say Brazil. How many players are from Brazil? There are too many players. So what we will do, we will count. A 24 players are for Brazil. So let me ping you, and I'll explain you again, but please try to see it and run it on your own first. Take some time, try to understand what's happening here, and I'll explain you. This is how they give you questions in interview. Lokesh, are you getting this? Arushi?
आ रहा है सर थोड़ा थोड़ा.
Arushi? Pankaj? Cheryl?
Can you show this previous command, like what we written?
I'll explain. I'll explain. 1 second. Yukti? Shivali?
Yes, sir.
You want me to repeat?
Yes, sir. Do it once.
Yes, I will do that. I will do that. So that's why I first went into a simple example to show you how filtering works. The simple example was, if you have a list, a Python list, you first need to convert it into an RDD using a parallelize function. And because a list is like a single column, filtering was very easy for you. Filtering was very easy. You have to simply use a filter function. And what is X? X is the input row, the input record. So as I explained you earlier, first value will go, then output will be checked, and then filter function will see whether it's true or false, right? So doing any operation on a single list is easy. But the problem will occur when you are asked, hey, this is a proper file, and in this file you have to do some analytics. Then RDD becomes quite weird. It's not that good. DataFrame is very easy. I'll show you. But if you have an RDD, for an RDD, this, let me copy this. So if this was a file, let's say this was a file and this was the first row, this was the second row. When it goes into RDD, RDD does not give it any special treatment. Still RDD will say, okay, this is first row, okay, this is second row, okay. RDD does not understand that it has to split on commas. RDD does not know anything about it. For RDD, this is just like full one value, one single value. One row is one value. This entire row, the first row, is one value. It does not give any special treatment to commas. So since it does not give any special treatment to comma, it does not know this is first column, second column, third column. No. For RDD, this is entirely one column, one single column. For RDD, the first row is like, it contains only a single column having this value. Now you need to tell to RDD, hey RDD, this entire first row is not a single column. It internally contains multiple columns, first column, second column, third column. So this entire is not one single column. Rather, there are multiple columns inside it. So RDD will say, okay, tell me, how should I understand it? So you will say, whenever you will see a comma, just say that it's a new column. So, okay. So you will say, this is what you're doing. Let me make it simple for you. Okay, so you can do like this also, don't worry. So first what you will do, on the original RDD, you will apply a map function and say split every row based on comma. So as soon as you split every row based on comma, then they will be treated as separate columns. All of them will become like this. Means all of this will become like separate columns. They'll start to become separate columns. So now it understand, okay, I have so many columns. See, this first row, this is first row which is split into columns. This is second row which is split into columns. So what I'm trying to say, if you look at the left hand side, this is how your left hand side was. System does not know that each of these are separate columns. But as soon as you splitted it, this is first column, this is second column, see, it splitted everything into proper format. Now, from all those columns, from all these columns, which is the column for your interest is nationality. So you will see this is like a list. 0th column, first column, second column, third column, fourth, fifth, sixth, seventh, eighth. Okay. So the 8th element of the array is your interest. So this entire list will go as an input in this map statement. What is the input now? Now here this X does not represent this. It represents this. It represents this form of the data. From here you can fetch the 8th index, which is I am fetching. So in this RDD, the new RDD, you will have what? You will have the nationality column. Sorry, if you say this dot collect. So you have just fetched from each row you have fetched. So from the first row you fetched the 8th index. From second row also the 8th index will be Argentina. Then the another row will come. From there also you will go and fetch the 8th index. So all the rows which are coming into the system, from all those rows you are now fetching the 8th index position. And in all of them the 8th index position is country name. So you will get a list of all the countries. So this is from the first row. This is from the second row of the file, third row of the file, like that. Are you getting me?
Yes, sir.
Now finally you have all the list of the, so each row, this is first row, second row, third row, each row here now is a country. Now this will become, now this output is, isn't it like this? Isn't it like this? Where you have only one column and you are just filtering on one column, saying filter X greater than 7, filter on X greater than 7. So here I cannot I say whether country is equal to Egypt or what, whether country is Belgium. So what I am doing, finally on this output that you see, which is my L2, on the L2 I am saying filter it where X, now this X is nothing but the country name, nationality, Argentina, Portugal, Brazil. So whether that X is equal to Brazil, if it is equal to Brazil, you are using a filtering, and now L3 will only contain what? Let's see, only Brazil. I'll say collect. Only Brazil. So those rows are getting printed where you have Brazil. But you don't need to see the data, you want to use count function. Now this is a action, whereas this were all transformations. So total 24 records.
This splitting was done on the first row only, or all the rows below that will be splitted on the.
What the lambda function will do? It will work on each row. First row, it will split. Second row, it will split. All the rows that are coming, all these operations.
All the rows in the ABC.
All the operations happening on each row, one by one. First row, second row, third row. Each operation is happening on each and every row.
Okay.
So in the first row, in the first row, the 8th index was having the word nationality, but in the other rows, the 8th index will not have word nationality, it has value
Country
for
name.
nationality.
Yes, okay.
Because first row was header, so that just helped me to understand which is the nationality column. So that's the problem with RDD, that you need to inform it everything. It does not know all these things on its own. Now we will do data frame, so you will see it will become very easy. But before that, I want all of you to run this. So this is one way of doing it. Let me ping you this also. But before that, what I pinged you was a function chaining. Like instead of writing all these things, like writing these 3 lines, you could have written this also. This is known as function chaining. Function, then output of this function will go as input to this function. Output of this function will go as input to this function. So it's like, it's more organized. So this is known as functional programming concept, using function on top of function, function on top of function. So instead of 3 lines of program, you can write 1 line of program. But it's fine if you don't want to do it. No necessity. Let's comment it. What I'm saying is, instead of writing these 3 lines, you could have written this also. So in that case, you just would have to say l.count, because L was the final variable. So l.count. Otherwise l3.count. So people don't use RDDs nowadays, just to tell you. Though don't worry, people don't use RDDs. They use data frames. RDD is an old thing. People have now moved out of RDDs because of some complexities. You have to think a lot in that. Please confirm me once you are done with this query. I'll also share this notebook. Let me share it right away. I have published this notebook.
Done, sir.
Very good. I have published this notebook and shared to all of you. You can refer to this during your free time. Okay, whatever is this notebook, I have shared to all of you. Let's move to the next step. Just ping me yes or no if you want me to move to the next step.
Yes, sir.
Okay. So now I am not going into more complex scenarios. That's it on the RDDs. Read about different transformations and functions, transformations and actions. Now we'll go into data frames. How to create a data frame. Please go through my GitHub account. If you go to my GitHub account, you will see Apache Spark there. You will see a lot of codes there. You want to use RDDs, map. There is something known as flat map. You can look at all these things. Is difference between Spark 1, 2, 3. We are using Spark 3. PySpark is what we are doing. We are not doing Scala and Java. These are all my previous notebooks. If you want to see, there is a list of my previous notebooks, Spark notebooks on machine learning and SQL. DAGs, as we saw, the directed acyclic graphs. Okay. Okay, anyways, leave it. I'm sharing the link. You guys can go through it. My GitHub account. But let me go into the hands-on. Now, when you want to now read the same file, but you don't want a RDD, you want a data frame. So you will say sc.read.csv. See, something similar to pandas. This was your file. So guys, it's so easy. Now we have moved into the next thing, which is the most important thing, how to create a data frame. So spark context.read.csv and the same file, but it will be becoming a data frame. Let's see, this will fail, okay? But let's see, this will fail. It's saying that the spark context object has no attribute read. Then you'll say, hey, Rahul, then why you are doing this? So let's do one thing. Now there is another predefined variable which is already there, known as SQL context. C capital. We'll check that. So there is already another variable SQL context. Please all of you check if it is there or not. SQL context, which is another variable like Spark context. We have SQL context. Just ping me if it is there. It's saying in the PySpark, if you have to work on, very good. In PySpark, you have to work on SQL.
Yes, sir.
Then you don't use Spark context, you use SQL context. So instead of SC, just change it to SQL context and see the power of this. But again, this is like a transformation sort of thing. Here, how to see the data? So here you don't have collect function, you have show function. See, I hope you guys are now getting why I am moving into data frames. Data is in the tabular format. You can use this also, df.show, but that's also showing data in this format only, but वो थोड़ा understood नहीं हो रहा है. Let's see this. Data is here also, data is separated into columns. C1, C2, C3, C4, these are the column names. But look wise, it is not that maybe appealing to people. But when you use display function, display is a Python function. You see the same data in the tabular format. Now you can run SQL on it very easily. A select star from this, where this column, that column, whatever you are interested in, you can do that. So I hope you're getting my point that as I started the class today, I told you we can, using the same file, we can create a data frame, RDD dataset. So sc.text file is the function that we use for creating RDD. SC does not have a function to create a data frame. At that time, I told you to just create a correlation to keep it easy. I told you that SC will be having a function to create a data frame also. I told you just to keep it simple. SC does not have any function for that. So SC itself gave you something known as SQL context. This SQL context is a child of SC only. Remember, SQL context is a child of Spark context only. So Spark context say, whenever you have to work on data frames, don't use Spark context, use SQL context, which is a child of Spark context only. Okay, so you will say this dot read dot CSV if it's a CSV file. JSON, if it's a JSON file. If it's a XML file, then there are other variants. Like you can read different files here. I'll show you that later. So I hope you're getting my point. So guys, please read that same file. Don't use the show function. Use the display function. So let me ping you. Please do that and confirm me if it is done. Same file now become a table. It's not a table, it's like a table known as data frame. So once you have created a data frame, so there is a different function for a data frame. Please confirm me that yeah, we are able to understand the difference. The data is organized. Whereas in the RDD, see, this was the RDD's data. RDD does not understand anything. That's why you have to tell to RDD, split it into commas, columns, and then this index is the nationality column. It does not understand anything. That's the problem with RDD. You have to write long programs. In data frames, you have to write very small programs. Okay, Pankaj, thank you. I'm waiting for more people to confirm if they are at this output. Bala, Madhu, Puneet.
Yes, sir.
Saket.
Done, sir.
Saket. Puneet, Saket, is it done?
Yes, sir. Yes, sir.
Okay, okay. Sagar. Honey, Ketaki. Okay.
Answer.
Okay. Perfect. So you guys are now understanding the power of data frames. Now let's see. Can anyone tell me there is some problem in this output? What do you think?
Header, sir.
Very good. Who is-
Headers.
Okay. Headers, right? So what we have to do? While reading the file, we have to say something like skip header, something like this. Maybe not this, but skip header is equal to true, right? Like first row is header, consider it as a header, right? There are multiple ways of doing it. I'm not going into this right now. So I already have the solution for that, but before that I am looking at some other solution. Okay. So you can go to the Databricks documentation also. No problem. So that option is not available there. So something like skip header is equal to true. So now I have to go into the another option. I was thinking of if we have any option here, but that's not there. So what you have to write is first of all, let me tell you what I was trying to do before I tell you what the solution is. See, what I was looking at is that do we have some options here like header equal to true, something like that, to keep it simple, because some programming languages have options where within the original function you can pass additional parameters like okay, header is equal to true, skip header is equal to true, something like that, that the file contain header. But here we don't have that leverage. What we have to do is we have to write these options. So you are saying, hey, SQL context, please read a CSV file for me. But before that, you have to put these options. You have to put some options. What are those? Options are whether header is equal to true or false. What is the file delimiter? Because it's a CSV file, you can skip this line. This is not needed. But let's say if the file contains some other delimiter, you should have specified here, like pipe or something. But otherwise, this is just an optional. Remember, guys, whenever you are reading a comma separated file, this line is optional. By default, it is always comma delimiter. Infer schema is equal to true means, okay, we have a header, but do I want to infer schema that what is string, what is int? If you don't write this line, every column will be considered as string, even the integer also. But if you say infer schema true, then it will make age as int. Otherwise, it will make it as a string only. That's it. Let's see this.
Black కూడా కూడా సూపర్ ఉంది నేను.
One second. Oh, this line got executed. Let me comment it. So we have FIFA ID, player URL, short name, long name. See, so as soon as you say header is equal to true, the first record moved into the header record. Delimiter, you don't need it because it's a comma separated file. Infer schema true. Yeah, what's the difference of that? Let's see. See, when you print the schema for the data frame, it's saying, hey, it's integer, string, 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 integer, integer, integer. So because you have said infer schema true, it makes integer column as integer. But let's say if I remove this line, it will make everything as string. See, are you getting my point? Infer schema, what is the relevance? What was the relevance of this line? Are you getting my point?
Yes, sir.
So I'm again telling you, whenever you have to read a file, you will say SQL context.read, and then if it's a CSV file, you will say CSV, and that's it. If it's some other file, you will say that. Option. These are standard options. You have to keep them as is. I just want to tell you one more important thing. 1 second. So this was one of the syntax, but this is the best syntax. You don't need to worry about anything if you know this syntax. Let me tell you, you don't need to remember multiple syntaxes. This is the best one. See what it is saying. It's saying, hey, hey SQL context, please read. Okay. You are specifying the format. See, databricks.com.spark.csv. You are specifying it CSV. If it's JSON, you will specify the format here. If it's any other format of file, you will specify that format here. Then options, so they are standard options, and then you will say load. So now, because this command was specific to CSV, but this is a standard generalized form where you just give whatever file it is. The only thing that you need to change here is the file format. Just specify that here and it's done. Okay. So you say, hey, SQL context, please read. This is the format of my file. This is a standard CSV format. A header hai, delimiter is comma, infer schema true. Okay. Guys, any question in this? Please run this command. I am pinging you this command. Please run it. Confirm me if you are getting this. So you can print the schema also. This print schema command was not there in RDD because RDD don't have a schema. RDD never have a schema. See, this is the excellent thing here. That data frame have a schema. Now you can say something like nationality and you can fetch this value easily. df.nationality. But in RDD, you cannot say RDD.nationality because there is nothing like nationality there. Everything is just a simple string. But data frame, you can refer a column like with its name. How to refer it, it's a different thing, but yeah, you can refer it. I'll tell you. Is it done? Are you able to see the files? So SQL context is used when you have to do SQL programming.
It's running, sir.
Okay, so SQL context will give you data frame, and on data frame we will do SQL. So now we will be doing SQL. So far we were not doing SQL, Spark SQL. Once you have a data frame ready, you can do Spark SQL, running SQL queries on a data frame. So you have a data frame available, which is nothing but like a table. So let's say I want to see how many employees are there above the age of say 32. How many players are there, not employees? So I have a DF already available. select count. What you want to do? Select count star from FIFA where age greater than 32. I'll tell you what I'm doing, but I just want to show you the result. 1379. So what you have to do, guys, now understand. See, whenever you have a data frame, you first need to convert that data frame into a table using a simple command, that data frame dot register temp table. You are creating a temporary table with the name of FIFA. So a data frame can be converted into a temporary table. This table will be only for your session. After that, it will be gone. This is a temporary table. Write %SQL, a magic word, in another cell and start working on this FIFA as its a table. So I'm pinging you this command. Please do it. And confirm me if it's done. Then I'll give you few scenarios. That's it for the day. We will just do some scenarios now in SQL. Take 5 minutes, do it and confirm me. Make sure you run this SQL in a separate cell because it's a SQL cell. It's a Python cell, it's a SQL cell because of %SQL. Please do it and confirm me.
Done, sir.
But understand it properly. See what have we done so far. Please have a recap in your mind. You can do everything, Sagar. Once you have, let's say you have multiple data frames, convert them into temporary tables. Let's say you have 2 temporary tables, you can join them. You can do anything that you want. But first convert a data frame into a table before you do anything, join, merge, anything. Okay, Sagar? So you need to first read 2 files in 2 data frames, create 2 temporary tables, and then start joining them here. Getting my point, Sagar, or not? Okay, perfect. So just remember, Sagar, if you have 10 files, you create 10 data frames, convert those 10 data frames into 10 tables, and then start doing any number of joins, union, intersection, whatever. The whole purpose was just to reach to this conclusion. After that, we are done. So if you look at, you are running a SQL on a file. You're running a SQL query on a file. But that file is in the form of a data frame. So this is the power of Spark. If you think that way, you are running SQL not on a table but on a file because of all the steps that you have done so far. So guys, take 5 minutes, reflect back. Okay, we have some time available. Please see through all the steps we have done today. And then I'll explain if you have any doubt anywhere. Okay, Neha. Okay, Adhyan. Mayank, Bala, Lakshya, Lokesh.
Yes, sir. Done, sir.
So nowadays, what we do, we simply, whatever file we have, we use SQL context, create a data frame. C is the schema, whether you want a schema with proper data types or with all string. Depending on that, you will select this infer schema thing. So dot read, dot format. So if you look here also, what you are doing, this is also a function chaining. Function on top of that, another function, another function, another function, another function. So this is function chaining, and this is a very big thing in today's world. This is known as functional programming. This is a very important field of functional programming. Java, Scala, Python, everyone supports functional programming to some extent. So if someone asks you what is functional programming, it's a very big thing, but this is one of the examples. Function chaining. Lambda functions are another example of functional programming. Okay. Now let's say what I want you to do, please. Now you guys will be doing it. Okay, just tell me who is the youngest player in this entire table. Can you run a command to tell me who is the youngest player? Guys, please do it. What SQL query you have to write to tell me who is the youngest player? So you already have a data frame, you already have a table. Everything is case sensitive here. When to use small, when to use capital, like T's are capital. So I'm giving you some time, please think and tell me the answer. Who is the youngest player? I'm waiting for all of you to ping me the command. Okay, Sagar, so I think you just said limit equal to 1. So just say limit 1, not limit equal to 1. Huh? But Madhu and Sagar, both of you are mistaking something. Yeah, Mayank, Shivali, you are correct. But Madhu and Sagar, just think again. You are missing something. If you see this, if you say this, there is nothing wrong in this, nothing wrong in this. You are saying select short name or star, whatever from FIFA order by age. First of all, it should be ascending. Yeah. Limit 1. Yeah. Someone says limit equal to 1. No, should be limit 1. Yeah. But don't you think that if there are 10 people of the same age, you will get only one? You will miss the other 9 people.
Yes, sir. Got it. Just now I'm saying.
So you cannot do this, right? To comment a SQL block, you have to say hyphen. To comment a Python, you say hash, right? You put a hash. Hash will not work here. Okay, so if you see the out command is already on my screen. Total these many people are there. Okay. Another benefit of using this notebook is the graphs. Let's see these options. You can download this data as well. Let's say you want to do some analytics and want to download the output of a query. You can download it. You want to create some graphs, click on this. See, it's creating the graph. You can change that graphical options using plot. Let's say based on age though is same for all of them. Let's say based on their weight, you want to group people and you want to see the count of whatever. So 3 people having weight 75, 1 person with 69. So whatever you want, you can do that. So what I'm saying is these notebooks also provides you the graphical options. Just click on this graph option. After that, you will get the plot options. This is x-axis, this is y-axis, and this is the aggregate function you want. On that, the type of charts, bar charts, pie charts, whatever kind of charts, you can create it and submit it along with your notebooks to anyone you want. Okay. Even the display function also gives you the charting options. So you can do that. Okay. So that's it, guys. The good thing is we will not be doing data sets. Why? Because data sets are not available in PySpark. They are available in Java and Scala. They are not available in PySpark. And there is no additional benefit that you get from data sets. There are some benefits in data sets, but DataFrames already provide you those benefits now. So you don't need to specifically study data sets. So mostly people working on PySpark, they use RDDs and DataFrames. 10% they use RDD, but 90% they use DataFrames. Or 99% they use DataFrames only. So that's it for the day. Now, similar to the functions in RDD, filter, map, all, we have the functions in DataFrames also. You can study that. We will do that in the next class. Okay. But what I want from all of you, on at least the same data, there are multiple files. Try to analyze those files, join those files, do some advanced queries on those files, do charting and plotting, do some advanced SQL, whatever comes to your mind on this FIFA dataset. Try to read a pipe separated file also if possible. If you have any pipe separated files, tab separated files, just try to read them and see how they looks like. Do all this analysis. And those who haven't submitted assignments, submit the assignments. Okay. So when we will be back, so next class will be on Thursday and Friday, because next today I have some medical checkups to be done because of some health conditions. So next we have Thursday and Friday, the class, and we will be doing machine learning in the next class. Next two classes will be your last classes, machine learning. I'm sharing my GitHub link. Please go through this Spark and whatever you will see here.
So can you share your notebook link also?
I have already shared it. Let me do it again. I need to publish it. I'll get the URL, copy it. I'll paste it. Okay. So please practice it. What is a cluster? How to upload the data? How to create the notebooks? How to read the files in RDDs and DataFrames? Just understand the difference between RDDs, DataFrames, and datasets. Read about them. And as we told, as I told you, Spark ecosystem. So we can now again have a look at it. So today we looked at the Spark core, which is the RDD. So what you learned in RDD is the Spark core Spark is RDD. Then we did Spark SQL, which is the DataFrames. So DataFrames, datasets are part of Spark SQL, which we did. Now explore more, do as many queries as you want. Spark streaming, which is real-time processing using Spark, is not in our scope. The next thing is the machine learning, which is in our scope. We will be doing it in the next two classes. We will take few machine learning models. So please revise your machine learning concepts also. I may ask you few questions around linear logistic regression or bias variance, learning rate, any such things. Graphics is again not in our scope, and Spark R is also not in our scope. But yeah, if you have to use R programming in Spark, you can do that also. Graphics also. Okay, so I hope now you guys are very clear about this diagram. If someone asks you, here is the RDD, here is the data sets and the data frames. What is this? What is this? What is this? What is this? All of this. Any questions before we end the class?
No, sir.
Okay, so today we didn't get the time to review your assignments, so I'm giving more time to people who haven't submitted assignment. This is the final deadline. Submit it maybe by today or tomorrow. Okay, please submit it at least before Thursday.
Okay.
Before our next class. But those who have already submitted, they will get additional marks for submitting it early as compared to those who submit today or post today. That's the 1 marks difference. Okay, but yeah, please submit it before Thursday's class. I want everyone to submit it who haven't done it. Okay guys, thank you. We will
Thank you, sir.
connect on
Thank
Thursday.
you.
Take care.
Thank you, sir. Thank you, sir.
Thank you, sir.
Mayank, you are there?
Yes, sir.
You want me to call down? 1 second, let me stop this. 1 second. Let me stop.